Okay, so this is optional video to explain homework solution. Hope this video can help those students who find difficulty how to apply natural deduction rules. So in class we talk about this proof strategy. So this would be a good guideline for you. So look at the formulas that you want to prove. If your goal is to prove F implies G, then in class we talk about try to have this assumption F and derive G and then use implication introduction rule. For the conjunction, I talked about derive each of F and G and then use conjunction introduction after that. And for disjunction, you can try to prove one of these formulas, F or G, and then you can introduce or introduction. And I said it's limited. It's because this is sometimes actually there are some formulas of the form F or G, but this strategy actually does not work. Unlike the other cases that I show here, those other cases always work. But for this case, F or G, this proof strategy is kind of limited. If you want to prove not F, again, you can try to assume F and then try to derive bottom. If you're successful on that, you can use the negation introduction rule after that. Okay. So the formula, okay. So the formula that we want to prove in 4 has this form. Okay. So look at the goal. What is the thing that we want to prove? This one has implication as the root node of the parse tree. So basically we want to prove this claim. At the very last line, we want to have P implies Q implies R. So this is actually line N. And try to get this one. So this should be your last line. Now, how do we prove this? We don't have premise to start with, but if you want to prove the implication form, then the strategy that I just introduced you says you have a box, okay, and assume P, the antecedent of this implication and the consequence of the implication here, so which you gives this format. Okay, so this is your line N, this is line N minus 1. Now the next thing is, okay, you have this now one assumption, that's good, you may be able to use it later, but if you look at the goal, again this has the form of implication. So the same strategy as before applies. So you can apply, you can have another box here. So in the box you start with the P implies Q, which is antecedent here, and the consequent P implies R is here. Okay, so that's line 2, and this is N minus 2. Okay, and after that, you look at now the sub-goal to prove, which is P implies R here. The same strategy again. So just repeating the same thing. So this line 3 and then minus 3. So what do we want to do if we want to prove this guy? Well, we can do assuming this guy and then try to prove this guy. Okay, that's all we have. Now we have no connective in the line n minus 3, but we have enough assumption to manipulate. So if we know line 1, 2, 3, what can we do? If you look at line 2 and 3, for instance, you can derive Q. Okay, so from line 2 and 3, we can derive Q, which is implication elimination for line 2 and 3, or modus ponens. Okay, and I didn't write this thing here, but it's basically all the first line of this box is assumptions. Okay, so I know Q is true, and what I can also derive from line 1 and line 3, okay, so I know P is true, and I also know P implies Q implies R is true, so then I can derive Q implies R, and this is an implication elimination for line 1 and 3. Okay, so, and that's it. So if we know this, line 4 and 5 will actually get line n minus 3. Okay, so n minus 3 is actually line 6, 7, 8, 9. So how do we get R? Implication elimination for line 4 and 5. Okay, and after that is straightforward application. So we actually fill all the gaps in the box. So line 7 will give me implication introduction for from box 3 to 6. Okay, and the next one is the outer box. So line 7 is from implication introduction to line 2 to 7, and then line 8 is implication elimination for line 1 to 8, and that's it. Actually, I think I got mixed up. So line 7 is 3 to 6, line 8 is 2 to 7, and let me just write here again. Okay, so this is line implication introduction for line 2 to 7, and this is implication introduction to line 1 to 8. So we are done with the proof. Okay, so let's look at the next problem. So okay, so let's look at the next problem. So here we are given this problem. Okay, so how do we prove this? Again, the last line should be the formula that you are given. Okay, so I'm copying that formula. Now, in order to prove this, we don't have any premise here, but we can try to prove using the first strategy that I introduced, the box. So in the box we have the antecedent here. Okay, so I'm going to write this antecedent here. Okay, so this is my antecedent, and then we have consequent, okay, which I'm going to write here. Okay, all right, so this is it. This is my assumption. Okay, and this is my line n minus 1, and this will be obtained from line using the implication introduction from box 1 to -1. Okay, so how do we prove this? So the idea is we have to prove P or R from this. So for this problem, actually the OR introduction strategy in the previous page actually does not work. The idea that works here is to use OR elimination rule. So think about this line 1 as case statement. So we have two cases, P and Q, as case 1. Case 2 is R. So if you can derive this conclusion P or R from each of these cases, then the proof is done. That's our proof strategy, which means that case 1 assumption is P and Q, and try to derive P or R as our first box. Okay, so first we assume this and try to derive this P or R. The next one is the same thing, case 2 assumption here, R, and try to derive P or R. Okay, so we have to fill in the middle. Okay, so if you have that, so this is our assumption. Okay, and this is also our case assumption. Now our goal is now prove each of the boxes. So in fact, if you look at the second box inside, this is actually easier to do because we assumed R, and then we can derive P or R using the OR introduction rule. So that's easy to do. Okay. I'm skipping the line number because this will be filled up later. So we are done with the second box. The first box, we have P and Q as an assumption, but we have P or R as the conclusion of the box. So how do we prove it? So idea is here is actually simple. We need only one step. We can derive P from P and Q. So this is an elimination from line 2. So this is line 2, line 3. Good. And from line 3 to line 4, this again, or introduction from line 3. Okay? Okay, so this is line 5, line 6, this is line 7, line 8, so we are done. We just need to fill the rest of things. So this will be 5, and this will be or elimination rule from case statement 1, and the first box 2 to 4, and the second box 5 to 6. So this is the proof. Good. Alright, hope this makes some sense. Now go to the next one. So in 6, we have modus ponens. Modus tollens. Actually, you can do this in a very simple step as just using the modus tollens. But let's try to do it without having modus tollens rule explicitly, because that's a derived rules. It's okay to use derived rules in the quiz and homework, but here as an exercise, we'll try to do without that rule. Okay. So the formula that I ask you to show is this guy. So again, you have no premise to start, but your goal is line n. So we have P and Q. P implies Q, implies not Q, implies not P. Good. So same thing again. So need a box. Okay, and P implies Q is the first, not Q implies not P is the last. So this is 1 and minus 1. Okay. So if you look at this thing again, look at this goal. The goal is not Q implies not P. So what do you need? Well, again, we need this another box. Okay. So not Q and not P. So if you can derive this is assumption. If you can derive not P, I don't know how to do this yet, but if I can do that, what I can get as line n minus 1 is using implication introduction rule to line 2 to n minus 2. So this is what I know. Okay, so now let's look at the subgoal here. Now this is actually not P. So how do we do? Again, it's the same thing. Okay, so if you look at the last entry of the table, in order to prove not P, what do you need to do? We can try to assume P and derive bottom. So if you can do that, we can use negation introduction rule. Okay, to the box 3 to something that we don't know yet. Okay, it's actually n minus 3. I don't know what is actual value yet. Okay, so done. So we simplified our formulas to prove from this guy to this guy to this guy to this guy. So it becomes simpler and simpler. But at the same time, what happens is we get very valuable assumptions here. Okay, so to manipulate this assumption, so the thing is from the bottom to top, we are actually from the end of the proof to the forward, we get the formulas, the goals to be simplified. So now we have to only prove this guy. On the other hand, we accumulate a lot of assumptions here, which we can use to prove this simplified goal. So that's actually the idea of the proof, going from the back front to the end, or end to the front. Okay, that's what you do. Now, what do we do here? So obvious thing is here we have P and P implies Q. So from this line 1 and 3, we can derive Q. So that's implication introduction elimination from line 1 and 3. Now once you have that inside this box, you know Q is true, but at the same time this box also can say can refer to the outer box not Q. So Q and not Q is actually getting the bottom. So we are getting this negation elimination rule from line 2 to 4. Okay, so that's the thing. So n minus 3 is actually 5. This is 6. this is 7, so this is 8. Okay, this is actually 5. Okay, and this is 6. And then the last one is, of course, in implication elimination rule from the largest box, which is 1 to 7. So we are done with the proof. Okay, good. Okay, so let's go to the next one. So next one was to prove this f and g is equivalent to g and f. Now, as I said in the description of the homework, basically this is a shorthand for the conjunction. Okay, so we can try to prove this guy. So I will say, actually, yeah. So this is something. This is actually what I show. Okay. So let's see. My last line here should be the whole formula. So f and g. Okay, so how do we prove this? Now, look at this last formula. The formula has the form of the conjunction. So our proof strategy tells us, why don't you try to prove each of them and then use conjunction introduction rule later. Okay, so we are trying to prove each of these. So what I expect to do is somewhere in the line of the proof, I want to derive this. Again, I don't have justification yet, okay, but if I can prove this and also I can prove the other one, I don't have justification yet, but if I can prove this, using these two guys and using and the introduction to these two guys, we can get the last rule. So now we have to look at only this. Okay, again, try to look at the simplified goal. Now, if you look at this goal, this is again implication format. So our proof strategy is to try to assume f and g and try to derive g and f. So this is line 1. Okay, how can we do that? Well, this is actually easy. From f and g, we can derive f and g. So this is assumption, then this is end elimination for line 1. And elimination for line 1. We can be a bit more precise. I don't actually mind if you omit this subscript, but in the textbook we have, say, the two versions of end elimination, which is to get the first conjunctive term or the second conjunctive term. Okay. All right. So now once you do that, we can use actually the end introduction rule. For the end introduction rule, we don't care the order of these two, so that's why we can shuffle the order. So we get end introduction for line 3 and 2. Okay. So then we will get this line using an implication introduction from line 1 to 4. Good. And the next thing is actually symmetric. So let me just write down. So what we are going to do is line 6 we assume g and f, okay, and line 7 we get g, line 8 we get f. This is our assumption, and from g this is conjunction elimination from line 6. Okay, actually first version. This is conjunction elimination for the same line, and then we use end introduction for line 8 and 7, so that gives me f and g. That becomes line 10 implication introduction for box 6 to 9, and then this becomes 11. And now we know that what is it? So we filled out this justification before, and for end introduction is applied to line 5 and 10. So we are done. Good. The next problem was actually discussed in the recitation section, so I'm going to skip it. So problem 9 is the last one that I'm going to say. So in this problem, you are given not f implies f implies bottom and f implies bottom. Okay, so how do we prove? Again, this has the form of the actually, I already replaced the implication, two-way implication with the conjunction of two one-way implications. So the last thing that we need to write here is the line that we wanted to prove. Good. So we'll use conjunction introduction, which means at some point we want to establish one of the conjunctive term, okay? And at another point we want to establish the other direction. Okay, we don't have the justification yet, but once we have that, this will be applied to each of these lines, okay, to get the conjunction of these two formulas. So then now look at what need to be done here. So again, if you look at this formula, we have the implication. So for the implication, again, same strategy. Assume not f and try to derive f implies bottom. Okay. So this is assumption, and this will be the implication introduction from line 1 to something. Okay. So now look at this goal. It's again implication form. So what can you do? Well, try assume f and try to derive bottom. Okay. So this is line 2, my assumption. Now we have to go from line 2 and 1 to derive this bottom. It's actually easy because we already know the contradiction inside this inner box. We already know that f is true, and we also know that not f is true because not f is outside outer box, but it affects also inner box. So we cannot actually use the negation elimination rule from line 1 and 2, so we can derive bottom. And once you have that, line 4 is implication introduction from line 2 to 3. Okay. All right, and then number 5 is easy. So this is implication introduction for line 1 through 4. Okay. All right. So that we are done with the first half of the proof. The next half, we are going to prove this guy, which means we have to assume f implies bottom and try to derive not f. Okay. So this is my assumption. And if I can derive box, of course, here we can use implication elimination, implication introduction rule to line 6 and something else that I don't know the number yet. But now if you look at the subgoal here, this is not f. So the strategy in the last entry there is, well, if you have this, try to assume f and try to derive bottom. Yeah. So if you have f and if you derive bottom, then you can derive not f. This is using the negation introduction rule. So the thing is, how do we go from this f and f implies bottom to derive bottom? Well, it's actually easy. This is just a one step. So we can have, this is assumption. Line 8 can be just directly using the implication elimination for line 6 and 7. Okay, so then we can get line 9 using negation introduction rule from the box 7 to 8. Okay, and line 10, we now know that the box is from line 6 to 9, and this is actually 11. Okay, so this is conjunction introduction for line 5 and 10. Okay, so this is a bit longer than the other proof that you have done, but again, it's same strategy used multiple times. So basic idea is you look at the propositional connectives to find out how to simplify the goals to prove. And at the same time, when you do that, you may have some good assumptions that you can manipulate. So the goal becomes simpler, and you have more assumptions to manipulate, so there's a higher chance that you can fill the box, you can fill the missing part. Okay? I hope this video makes some sense. And we already have all the solutions in the Blackboard, so take a look at it carefully. Basically, my advice to you is the same. Try to do this all by yourself without consulting any other materials. If you got stuck, come back to this video or the textbook or slides or lecture videos. Hopefully that will tell you which part is missing. So you have to find out which part is the part that you don't do it by yourself. That's the weak point that you can try to improve. Okay? Alright, so wish you good luck with the quiz and the test.